Good morning. I'm Klara Finkele, and together with Tamara Hochstrasser, I coordinate the AGMET group. And this morning, I'm talking to you about the developments and applications of a national soil moisture monitoring network, a project that the AGMET group has undertaken. So first, I give you an outline of who we are and why we are looking at soil moisture, because basically there are many applications. And what is measured, how it was measured in the past, what we're doing at the present, and what our future plans are, and then where we plan to implement this national network and co-location with existing networks. So the AGMET group is a joint working group on applied agricultural meteorology that was established in 1984. It's a voluntary group. We have a website, agmet.ie, and it is convened traditionally by the agricultural meteorologist of Meteorology, which is currently me, Klara Finkele. And I have taken up this post about 2 years ago after having spent about 10 years as a forecaster in Meteorology. And the treasurer is Tamara Hochstrasser from UCD. And the members really draw from universities, JAGAS, GSI, EPA, OPW, DAFM, AFPI, Northern Ireland, anyone really interested in any aspects of agricultural meteorology. And in January 2020, after having taken up the post of AGMET in Meteorology, we convened a meeting and I put up a couple of projects we could possibly undertake, and soil moisture was really the one that everybody honed in on, and there's about 30 people or so in that working group. So why soil moisture? Because basically it has so many applications for most agriculture. Any plant growth is controlled by soil moisture. Also nutrient management like slurry spreading depends on soil moisture. Because of the nitrate and phosphorus leaching or overland flow that is detrimental to water quality. And also with water resource management, if there's too much soil moisture or too little soil moisture, and too much soil moisture, of course, then leads to flood forecasting. Also, too little also means there's an increase of forest fire risk, but also logging operations depend on trafficability, which is dependent on soil moisture. Soil carbon sequestration depends on soil moisture because the way we manage our land, then the soil can become a sink for atmospheric carbon. We also need soil moisture measurements for our initial conditions of numerical weather predictions, so for an analysis as well as the verification of our predictions. Also, in terms of longer term variables, such as climate change, to assess climate change, soil moisture has been declared as an essential climate variable by GCOS, which is the Global Climate Observation Systems group. And here is a sort of a diagram that shows temporal as well as spatial dimensions. Like, you know, we're looking at hours, days, weeks, months, as well as hundreds of meters, kilometer, tenth and 50th of kilometer. Like the 10th to 50th kilometer is where the climate, global climate models are sitting. Numerical weather predictions models currently are at around the 1 to 2 kilometer grid scale. And agriculture sits around 100 meters, forestry as well as 100 meters, but they have a longer time scale. And this was a diagram looking at different satellites and where they sit in terms of space and time scales. But this gives you the difficulty really in terms of spatial and temporary scales that hydrology and the soil moisture in particular looks at. And why? Why are we looking at soil moisture? Why do you think it's important? So if we look at the whole hydrological cycle and who does what and measures what or interested in what, like if we start with the clouds and the precipitation, so Meteorology measures rainfall, and then it's intercepted by vegetation, and then it infiltrates into the soil. Now, soil moisture itself isn't really measured by anyone. It's more like a black box. Like, for instance, for groundwater, GSI, that is looking at groundwater, they actually said the top 1 meter of soil, to them, they regard as a black box. And then we have through flow, overland flow, stream flow. OPW measures stream flow, groundwater seepage, runout, evaporation, water vapor, condensation. And then so here is the entire hydrological cycle. And certain aspects are measured by various agencies, but there is this black box of that soil moisture, that there are no long-term measurements. There's projects and short-term measurements, like a couple of years or so, but no real long-term measurements. So coming from an atmospheric perspective and being a meteorologist, we look at the surface energy balance. You know, we have the net radiation that goes into ground heat flux, and the net radiation minus the ground heat flux is the available energy for either sensible or latent heat flux. So this is where the partition is into sensible or latent. And how much goes into latent heat flux really depends on how much soil moisture there is available and the atmospheric demand. And the surface energy balance in numerical weather prediction model is used to determine the near surface temperature. So that is the balance that determines the temperature. And a typical surface energy balance through the day looks like this. Here there's like no clouds. So you have like this classical sinusoidal net radiation, and then the sensible and latent heat flux. And that really depends on how much atmospheric demand there is, as well as how much is available soil moisture for evapotranspiration or latent heat flux. We call it latent heat flux, you call it evapotranspiration. And evapotranspiration is really the link between physics and biology, or the link between atmosphere and the soil. Or put in another way, it's the soil, plant, atmosphere continuum or interaction. And physics, which I'm more used to, is determined by conservation law, conservation of mass, conservation of energy, conservation of water. Whereas biology, the plant, that is determined by optimization or minimization. Minimization of the stomata not wanting to lose water, but maximizing the CO2 uptake for this photosynthesis process. And that's really what drives evapotranspiration, that photosynthesis process and the opening of the stomata. But the plant is trying to survive and optimize growth. So this is a very different world to the physics world numerical weather prediction looks at. But there is also evolving biosphere models now. But the crux of this is soil moisture is critically important in that process near the surface. So if it's so critically important, why isn't soil moisture measured then already? Well, the short answer is because it's difficult. It's difficult because of horizontal and vertical heterogeneity. It's extremely heterogeneous, whereas in atmosphere, because of the wind, the turbulence, things get mixed up. There's more, it's a lot easier in the atmosphere. So who should do it then? That's really sort of like the difficult question, even more difficult question. Who should do this? And we really do need long-term measurements that are needed. So we looked at, in terms of the AGMET group, we looked at a collaborative approach and who is doing what already and where can we draw resources from. So in the center here, we have Meteorology and Chagas. Meteorology, we have an operational setup with climate weather stations, operational database, the forecasting, the modeling, the reporting, the communication. And with Chagas, we have the soil hydraulic properties, the agricultural cancer program, the heavy soils program, pasture-based Ireland, the newly launched signpost farms, and the National Agricultural Carbon Observatory that's being established very shortly. So That's the agricultural part. Meteorology is more the operational part. And together with a few other agencies like the EPA, OPW, who do hydrological data, river flow data, water quality, DAFM, who do forest fire risk, and they're interested in soil moisture, do geological survey, they do groundwater monitoring, the drone survey, TALUS, and the Terra project, Terra Soil project. There's also some interesting citizen science, cheap distributed sensors. The problem with those is they don't live very long, and they're sort of, but there is something said for like many sensors, and how do we make use and sense of this data together with high quality, few sensors and remotely sensed data, as well as satellite drones. And that's where artificial intelligence comes in, and data fusion and the digital twins. There's emerging projects and science that can help us with this. Also down here and on your left, carbon nutrient dynamics, the ICOS, the Integrated Carbon Observatory System, the National Ecosystem Monitoring Network, which is a statutory requirement for Ireland. So there is various networks that we can piggyback on or utilize existing resources to see how we could establish a national soil monitoring network. How was it done in the past? Well, it's not exactly soil moisture, but we used to have a lysimeter network that was established in the 1960s, mainly at Chagas sites as well as Valencia. But then that got discontinued in the early 2000s. And at the moment, we model soil moisture with a very simplistic hydrology model. But there is no verification. So it's just a model. So it's just an estimate. So the future, we thought of looking towards the cosmic nutrient ray sensors to measure soil moisture, because it measures about a radius of 200 meters of that volume of soil down to between 20 and 40 centimeters, 50 centimeters, depending how wet it is. Then you get an average soil moisture for that volume rather than one point. So that is what this is rather attractive. And in fact, the cosmic ray is becoming, sort of more widespread. And there was a session about 2 years ago at the EGU, Cosmic Ray Across Scales and Disciplines, the new frontier of environmental research. So it has that attraction that it gives you this footprint of a radius of around 200 meters of what that soil moisture, how much water there is in that volume of soil. This is the setup for the UK. They have about 51 stations. So you have a general MET station and data logger. You also have a soil moisture probe, a point probe, as well as the CNRS probe. This tube here is the receiver of what the cosmic ray got attenuated by the water in the soil. And then through the attenuation, you can infer the soil moisture of about 200 meter radius in that soil, in that volume of soil. So as I mentioned, the Cosmos UK network got established in around 2013 and has 51 stations, and 3 are in Northern Ireland. This development was done in Arizona, at the University of Arizona. Tim Shuttleworth in early 2012. And there's a network across the US. There's a network across Australia with about 15 stations. India is developing a network, and there's several groups in Germany that are working on this research, how to use the cosmic rays to measure soil moisture. And they had a catchment in one summer over a period of 3 months, where they intensively had sensors, overlapping sensors. These circles are basically each a cosmic ray detector and overlapping, so they mapped a whole catchment in southern Bavaria here. This is the European network. There was a workshop last October where the different research organizations got together, and there was this idea of establishing a European cosmos network in light of the continental drought event of 2018. So there are emerging networks that and the UK being the first national network to measure soil moisture, and that's one of the attractions of this. So where should we look at establishing the soil moisture network? Well, first and foremost, it has to be long-term measurements and secure locations. Also, the climate and rainfall regime from low to high rainfall, as well as temperature and so on, covering a range of soil types from mineral to organic, and also covering a range of vegetation types, pasture, crop, and forests. And co-locating with potential soil moisture sites with existing stations, such as various synop stations that we have already, for instance, with Johnson Castle, Oak Park, Moore Park, that are at Chagos sites. UCD Lions would be one of potential sites. ICOS, carbon towers, the National Ecosystem Monitoring Network. So, and the 14 flux towers from the National Agricultural Carbon Observatory. So there are various potential sites then looking at the different soil types, the vegetation types, climate regimes. So this is where we are at the moment, trying to figure out what would be the best network design and network setup. So hopefully I can present something a bit more tangible in a year or 2 years' time when we have actually developed this network. So thank you for your attention.